Newton's first law is one of the most beautiful laws in all of physics, really. It anticipated special relativity and general relativity, and it showed what a just incredibly deep view of forces Newton had. We teach you Newton's second law first. Newton's second law is F equals ma. If you want to be a little bit careful here, it's F net, the sum of all the forces on an object, is equal to the mass of that object times the acceleration of that object. Newton's first law is often stated like this. Objects at rest tend to remain at rest, and objects in motion tend to remain in motion. It's often stated like that. And what that means is if there's no force, so I'm going to put a 0 on the left-hand side of the equation. That's a vector 0. If there's no force, then we have 0 equals ma. And the solution of 0 equals ma is either v equals 0, that is no motion at all, or v equals some constant vector, that is you move in some direction and you just keep continuously moving in that direction. So there it is. If there's no force, objects at rest tend to remain at rest, and objects in motion tend to remain in motion. And the tend to just means maybe there's little forces like bits of friction that I haven't identified yet. But if you actually get a situation where there's no forces at all, objects at rest remain at rest, and objects in motion remain in motion. Now you look at that and you go, well, that's just a special case of Newton's second law. So a lot of people incorrectly think that Newton's first law is content-free. It's actually not true. And actually Newton's first law is needed to even state Newton's second law. What Newton's first law actually is, and here's, I think, a better way to state it and appreciate it. Newton's first law is actually a statement that you can find certain coordinate systems. And in those coordinate systems, if there are no forces acting on an object, then that object, if it's rest, will remain at rest. And if it's in motion, it will remain in motion. So Newton's first law is a statement about coordinate systems. So I wrote it up the way I like to say it. There are coordinate systems, or reference frames is the more technical term, rather than coordinate systems, which kind of suggests numbers and meters and things like that. Just reference frames, viewpoints. There are viewpoints, which if there are no forces, then objects at rest remain at rest, and objects in motion remain in motion. The reason we do Newton's first law after Newton's second law is because essentially this is too deep to appreciate yet. And so it's a bit of an aside. And we're going to go on next to 5.7, which is free body diagrams. And you really don't have to worry about how deep and beautiful this is yet. It will dawn on you in coming years.